Hello and welcome. This video is brought to you by Science Visualized. Today we're looking at functional groups. What are functional groups? Functional groups are families of organic compounds that are grouped by common structural features. So a functional group is a collection of atoms within a molecule that has common bonding patterns, and they react in a typical way. So they have a characteristic way of reacting. And the functional group's reactions is generally independent of the molecular structure. So that means if you can identify a functional group in a molecule, then you can predict what kind of reactions that molecule can participate in. Functional groups affect several things, including the reactions of the molecules, the structure and conformation, and also the physical properties. That will be melting point, boiling point, and other things. Common functional groups. The first one, number one, is alkanes, and this has all single bonds. Remember, carbon makes 4 bonds, so the simplest alkane will be CH4, carbon with 4 hydrogens, because hydrogen makes 1 bond. And then the next one is ethane, where you have 2 carbons, each of them with 3 hydrogens. And then you can also have a cyclic system here, where we have 6 carbons, 1, 2, 3, 4, 5, and 6. Each corner is a carbon. That's a cyclohexane. And then we have a straight chain here with a side group. So 1, 2, 3, 4, and 5. So that will be a pentane, but you have a methyl group. So that will be 2-methyl pentane. The next one is alkene. Realize that with alkanes, the name ends with A and E. Alkenes, the name will end with E and E, and they contain at least 1 double bond. So for example, when you look at this, you have carbon-carbon double bond. And then this one here, you have 1, 2, 3, and 4 carbons. So between carbon number 2 and 3, you have a double bond. This one here is a diene because you have 2 alkenes, but it's a cyclic diene. And here you have an external double bond. So you have a cyclopropane with a double bond outside the ring. Number 3, alkynes. Alkynes contain triple bonds. As you can see here, we have carbon-carbon triple bond. And here we have 1, 2, 3, 4, and 5 carbons. So between carbon number 4 and number 5, you have a triple bond. So carbon number 4 and 5 are alkyne carbons. Number 4, alkyl halides. Alkyl halides contain an alkyl group, which we will call R, and a halogen, which we will call X. Halogens, that's X, are from group number 7A, so that will be bromine, chlorine, fluorine, and iodine. So for example, alkyl chloride, alkyl bromide, so in this case the alkyl group is methyl, in both of these cases, methyl chloride, methyl bromide, and then here you have an alkyl iodide, and here you have a cyclic alkyl chloride. Next we look at alcohols, number 5, they contain an alkyl group and an OH. So has carbon-OH bond. Examples of alcohols, like in this case, you have methyl alcohol. Here you have ethyl alcohol, that's ethanol, that's what's found in beer and wine. And here you have another alcohol, so you have 1, 2, 3, and 4 carbons, so that will be 2-butanol, or butane 2-ol. And here you have a cyclic alcohol, so that's cyclohexane alcohol or cyclohexyl alcohol. Number 6, amines. Amines contain carbon-nitrogen bond, where the nitrogen can have 2 alkyl groups, 1 alkyl group, or 2 hydrogens. So it has carbon-N bond. Example of that will be methylamine, and then here we have 1, 2, and 3 propylamine. Here you have a cyclic amine, and this is actually a secondary amine because you have 1 and 2 alkyl groups connected to the nitrogen, and therefore you only have 1 hydrogen on that nitrogen because nitrogen forms 3 bonds. Number 7, ether. Ether contains carbon-oxygen-carbon bond. So for example, here you have a dimethyl ether, you have a CH3 or CH3, so 2 methyl groups, dimethyl ether, methyl ether or dimethyl ether. In this case you have 1 and 2 carbons, 1 and 2, so diethyl ether. Here you have a cyclic ether, and then here you also have another ether. They all contain carbon-oxygen-carbon bond. Number 8, thiols. thiols contain carbon SH bond. So these are very similar to alcohols. Remember, sulfur is just below oxygen on the periodic table. They are both in group 6A. So you have carbon SH bond, and therefore thiols will participate in similar reactions with alcohols. Example here is methyl thiol, here is ethyl thiol. One thing to know with thiols is that they have a smell that's like skunk. So anytime you see a chemical that contains sulfur in the structure, or SH, expect that chemical to have a pungent smell, a very strong smell, like skunk. Number 9, sulfide. Here you have carbon sulfur carbon bond, as opposed to here we had carbon sulfur hydrogen. So that's thiol. Now it's sulfide. This is similar to ether. Remember we said ether, you have carbon oxygen carbon bond. So an example of that would be methyl sulfur ethyl ether. So this is also another example. Number 10, disulfide. In this case you have carbon sulfur sulfur bond. So that's an example of that, and that's almost similar to what we call peroxide, 10B, peroxide. And this is where you have carbon oxygen oxygen bond. If you have carbon oxygen oxygen hydrogen, that would be hydrogen peroxide, or it would be hydroperoxide, but you could also have an alkyl group in this position. Number 11, carbonyl functional groups. Carbonyl functional groups contain carbon double bond oxygen, and that's what we call carbonyl. And there are many examples of carbonyl functional groups. The first one is an aldehyde. Pay attention to that L, aldehyde. So look at this. You have an alkyl group, carbon double bond oxygen, and then you have a hydrogen. So if you look at that, it almost looks like you have an alkyl group, carbon double bond oxygen. So that looks like an L if we ignore the hydrogen. Or you could have it the other way. You could have carbon double bond oxygen and then alkyl group, and that will look like an L that facing that direction. So that's an aldehyde. It has a carbonyl, but one side of the carbonyl you have a hydrogen. Related to that is a ketone, and ketone, I usually tell my students to look at it as a key. So you have an R carbon double bond oxygen and another R group. So two alkyl groups on either side. It's almost like what you have there is a key like that. And then you have an alkyl group here, and then here you have carbon double bond oxygen. So that will be a ketone. And then number 11B, we have an amide, and amide is CH3C double bond oxygen with NH2 here. So it could be NH2 or NHR, different types of amides, primary, secondary, and tertiary, depending on how many alkyl groups you have on that nitrogen. And this amide is different from an amine. An amine just has an alkyl group and then NH2. But now we have a carbonyl group, carbon double bond oxygen. The next one is carboxylic acid, and carboxylic acid has alkyl group, carbon double bond oxygen, and then an OH. So that's different from an alcohol. An alcohol, you just have carbon OH. There's no carbon double bond oxygen. So here, the same carbon that has double bond oxygen also has an OH group. So that becomes a carboxylic acid. And then the last one in this case is acid halide. So acid halide, in this case we're looking at acid chloride because you have a chloride at that position. So you have alkyl group, carbon double bond oxygen, and then now you have a halogen. In this case we have a chlorine, but you could have a fluorine, bromine, or iodine. So it will be acid iodide, acid chloride, acid bromide, or acid fluoride. These are actually the most reactive carboxylic acid derivatives. The last one, 11E, you have alkyl group, carbon double bond oxygen, OR at that position. So instead of what we have here as an OH for carboxylic acid, now you have an OR, and that becomes an ester. And esters are very sweet smelling compounds. They're actually found in fruits. A lot of fruits have different types of esters, like pineapples, apples, bananas. Each of those are associated with different types of esters. 11EF, RC double bond O, oxygen, and then you have a carbonyl there like that. So that one there is called acid anhydride. So these groups where you're starting with carboxylic acid and then you're adding other things like halogen in that position, or you alkoxy group, or R, that becomes an ester, or in this case you're adding a carboxylate group, it becomes an acid anhydride, or even the one with the amide with NH2, all those are called carboxylic acid derivatives, so CADs. And the most reactive carboxylic acid derivative will be acid halide, so that will be number 1. And then the next one will be acid anhydride, number 2. And then after that, the third one will be esters. And then after that, number 4, which will now be the real carboxylic acid, and the amide. The amide is the least reactive, number 5. The aldehydes and ketones are not really carboxylic acid derivatives because you have an hydrogen there or you have an alkyl group. Thank you very much for your time. Please subscribe and support the channel if you enjoyed the presentation. Bye.